Hello college algebra student, this video is for chapter 5.3 graph polynomial functions. So quadratic function, we learn how to graph it by looking at vertex, but polynomial function is a little harder because there's not one vertex. It turns and it has a lot of like X Intercept. So the best we can do is just sketch a graph. For detailed graphing, you really have to wait until you learn calculus to find the turning point coordinate. So but in order to just get a good sketch, the two important things that we need to know is the zeros or the x-intercept of the polynomial functions. So we can find all the vertices, all the turning point vertex, but we can find the x-intercept. So zeros are used to determine local behavior. We call them local behavior because all polynomial function will have n behavior where the graph will go to infinity or negative infinity, but locally in the middle they will turn. So and then when it turns, it might go through the x-axis, and that's the x-intercepts. So the process to find x-intercept is factoring primarily. And then if they are not factorable, what can we do? We would use some method that we will talk about in 5.4 and 5.5, which is synthetic division to factor them. So primary factoring. And it turns out that actually for any polynomial, you can for sure factor it into a linear factor or quadratic factor. It is very interesting that the building block of polynomial functions are linear factor and quadratic factor. So let's look at how to factor. Usually you factor GCF first, see if there's any like power of x that you can factor out or a whole number that you can factor out. Second is if you look at there is difference of square. If you have something like a square minus b square, you can factor as a plus b, a minus b conjugate. If you have binomial, you can use diamond method to factor or grouping. And if it is terms of it's a binomial, but you have quadratic form term, so meaning if you have a term of x to the 4 and x squared, they are square of each other, you can use substitution to factor. Or if you have x to the 6, x cube, these two terms, so they are also square of each other, you can also use substitution to factor. Of course, you can factor cubes. X cubed minus x cubed minus b cubed can be factored. X cubed plus b cubed can be factored. And then after you factor everything, you can find the zero by zero product properties or quadratic formula. Okay. So first of all, let's look at zeros of the following polynomials. So I have a lot of example here. So first is a very simple one, two terms, and they can be factored by GCF. So find zero. Find zero means y equal to 0. So 0 is on this side, so x5 minus x cubed. And we want to solve for x. So solve y equal to 0. Okay. And so the highest GCF is x cubed. So we will write factor x cubed out. And then we do x squared minus 1. So now is it all factor? Oh, not yet. X squared minus 1 can factor more because they are both square. So x minus 1, x plus 1. After that, we can split them into x cubed equal to 0, x minus 1 equal to 0. After you factor principle of zero product, x plus 1 equal to 0. So x is equal to 0, x is equal to 1, or x equal to negative 1. So that is the three zeros. And of course, you can plug it back to find the y coordinate. Second one, we have three terms. So do I have GCF? We always check if there's GCF. Oh, they all have x, so I'm going to factor the x out. So 0 equal to factor the x out is x squared plus x minus 20. So this become a binomial with x squared, so I can use diamond to factor 20. 1, right? Multiply to be 20, add to be 1, so it's 5 and 4, minus 4. So 0 equal to x plus 5, x minus 4. And then use zero product property, x is equal to 0, x is equal to negative 5, x is equal to 4. So that's 3 zeros. After you factor GCF, you factor more. And later on, you will use this to graph the polynomial. A sketch, not the whole graph. Of course, right now we have decimal. You can actually use decimal to check, but you need to know this basic. Okay. First, GCF. Do I have GCF? I can factor x squared out. I can factor 2 out, right? So 0 equal to 2x squared. If I factor 2x squared out, this becomes x squared. If I factor 2x squared out, this would be 3x. If I factor 2x squared out, it would be minus 10. Yeah. So now this is a binomial of x squared, so I can use diamond again. Negative 10, negative 3. What number when you multiply is negative 10? When they add their negative 3 is 5 and 2, right? Negative 5 plus 2. So 0 equal to 2x squared, x minus 5, x plus 2. Here I do not give very difficult factoring. But you should review all your factoring. Factoring is kind of really important. So that's all, right? I don't have another factors. They're all factors. So x is equal to 0. X minus 5 equal to 0. X plus 2 equal to 0. So that's 3 zeros. This 0 is a repeated root. You have x squared. So x equal to 5. X equal to negative 2. This is repeated. Okay. And there is a term that describes it. It's called the multiplicity. We'll talk about that later. What about this? This has 4 terms. So for 4 terms, usually we do grouping. Okay. Do group by together. So between these two, the common factor is x squared. 2x minus 1 minus common factor is 4, right? Also 2x minus 1. I change it to minus because I insert a parenthesis of negative 4. So this would change to negative 1. So then I would have x squared minus 4 times 2x minus 1 because 2x minus 1 is a common factor. Now x squared minus 4 is a difference of square, so factor one more time. So 2x minus 1. So here I have x equal to 2, x equal to negative 2, x is equal to 1/2. I didn't split it, but you can just imagine that I split it up into 0, so these are 3 zeros. The next one, it is 3 terms, so it seems like I can factor, but it's not x squared, it's x4 and x squared. So I can think of u is x squared, u squared is x4. So we place them by u. U square minus 8u plus 12. So this becomes quadratic. I can use factoring 12 and then negative 8. So what two number will be negative 2 and negative 6? When they multiply, they're positive 12. So 0 equal to u minus 2, u minus 6. Right? 0 equal to x squared minus 2, x squared minus 6. Okay, so can I find the 0? So these are not factorable because they're not perfect square, but I can find 0 by doing this. And x squared minus 6 equal to 0. So x is equal to plus and minus square root 2. And x is equal to plus and minus square root 6. They're not whole number, but you can still find 4 zeros. The same here. So I have 3 terms of x to the 6, and x to the third. This x to the 6 is the square of x third, so I would replace this by u. And so x to the 6 will be u squared. So to solve 0, I temporarily say this is u squared minus 7u minus 8. Become a quadratic, so I can factor by diamond. Multiply negative 8, add negative 7, so be 1, 8, right? 1, negative 8. So factor it as u minus u plus 1, u minus 8, but it's still u. We don't want that. We want to plug it back in x cubed. So 0, you go to what? X cubed plus 1, x cubed minus 8. So we can factor more. Be x plus 1. What's the other one? X squared plus AB, right? Minus AB 1x plus 1. And then this would be factored as x minus 2 because the cube, right? X squared plus 2x plus 4. So all of these two are not factorable because they're just not. So the only answer would be x is equal to negative 1. The 0 will be an x equal to negative 2. So you see, although it has x to the 6, but it only have 2 zeros. So that's this is the factoring and finding 0 part. Let's look at what is the next part, which is graphing. So I think I'm going to do this in the next video because I don't think I can finish graphing in all of this.